Hi students, welcome to our Biostatistics and Epidemiology. For today's lecture, we will discuss your sessions 5 and 6, wherein the main topics are about your epidemiologic study cycle and measures of diagnostic efficacy. Again, for your MLS 054 or your Biostatistics and Epidemiology, for the lecture part, we will discuss the epidemiologic study cycle and measures of diagnostic efficacy. So for your learning outcomes, at the end of the lesson, you students must be able to, number 1, identify the 4 steps in epidemiologic study cycle. Number 2, identify the errors in epidemiologic study. Number 3, familiarize the different parameters of diagnostic efficiency, including sensitivity and specificity. And lastly, identify different measures of disease spectrum. To start with our discussion, let us define these terms first. Number 1, population. It is simply a group of people with common characteristics such as age, race, gender, or a place or residence. A target population is a population for which you would like to make some conclusions. So here are some of the examples. So when we say population, it doesn't necessarily mean that we're talking about the people in a specific place. Let's say population of the Philippines, the population of Africa, the population of Southeast Asia. So pag sinabi po nating population, it can be anything or any group that has a common characteristic. For example, na nga po dyan yung mga age, race, and gender. So here are the examples of your population. Residents of Mumbai, ayan, it can be categorized as population. What else? Members of Blue Cross or Blue Shield. Ayan po. Postmenopausal women in Massachusetts. Okay? Coal miners in Pennsylvania. Male physicians in United States. Ayan. Members of BUSPH intramural softball team. So when we see population, hindi naman po tayo extremely nag-rely sa large group of people. Okay, it can be as small as 10 or as small as 15 as long as they share the same common characteristic. Next, we have the sample size. It is the number of elementary units from whom data is collected from. It should be determined during your planning research. So kung babalikan natin yung slide natin, pag meron tayong population, dito natin kukuhanin yung sample size natin. Okay? If your population is too big, and then you're going to conduct a study, the next step for the researcher is to get the correct sample size. So kukuha lang po tayo ng mga representatives of the population using a proper sampling technique. Again, sample size po yung tawag doon. Another example, kung meron kang population na 15 million women in the Philippines, so hindi naman po natin sila lahat mai-interview for a study, hindi ito feasible. So the next step for the researcher is to get the correct sample size and then doon na tayo magpo-proceed doon sa ating study. Okay, next term is the mortality. It refers to the number of deaths that have occurred due to a specific illness or condition. Okay, when we say mortality, number of deaths. Okay, yun lang po siya. Next, when we say morbidity, it is the state of having a specific illness or condition. So yung main difference ni mortality kay morbidity is that mortality, yung number of deaths, morbidity, buhay pa po si patient. Nagkaroon lang po siya ng specific illness or nagkaroon lang siya ng specific condition. Next, we have ratio. It is the relationship between two numbers. It does not relate to a particular time. Also, there is no implied relationship between the numerator and the denominator. So, ang mga classic example po natin for the ratio is yung the ratio of women to men. Okay, 1:1 para mga ganun. The ratio of unvaccinated children to vaccinated children. Okay? So, wala pong sinasabi ditong direct or implied relationship between the numerator and the denominator. Let's say yung women and the men. Okay? Wala po silang direct relationship. Whereas for your proportion, proportions are created by dividing a fraction of the population by the total population. Everyone in numerator is included in the denominator. So, ang difference naman po nito, si proportion, ito yung pinagawa ko sa inyo last meeting na kung saan yung meron tayong numerator and denominator. Si numerator is part of the denominator. Parang ganon. So ito yung dito na pumapasok yung mga example nung prostate positive patients, parang men who have prostate cancer versus yung denominator natin na men lang. Okay? Or example, 54-year-old male who have cancer, who have prostate cancer. Dito naman, 54-year-old male lang. So, yung 54-year-old males natin who are having prostate cancer, they are part of the population na 54-year-old men lang. Okay? The numerator is part of the denominator. Yun yung proportion. Pag kay ratio, wala pong relationship yung nasa numerator and the denominator. Okay? So, yun yung kanilang main differentiation. Next term is the sensitivity. It is the proportion of individuals with the disease who test positively with the test. Sensitivity is usually expressed as percentage. So, for the sensitivity, we are trying to look for the true negative. Okay? And we're trying to avoid to detect yung mga false. We're trying to detect the true positive and we're trying to avoid to detect the false negative. Okay, again, ang palatandaan po natin dyan, if you're talking about sensitivity, ang gusto nating malaman dito, ang gusto talaga nating ma-detect, yung mga true positive. At ang we're trying to avoid the false negative. So, ang magandang mnemonic or palatandaan is itong false negative, yung N, sensitivity. Ayan. We do not want to miss yung mga patients or subjects or population natin that possess the characteristic and hindi po sila dapat mag-false negative. So, dapat ang ating research or ang ating ginagawang kinakandak na test ay sensitive. Next is your specificity. It is the proportion of individuals without the disease who test negatively for the disease. So, ang dinadetect po natin dito is we're trying to detect the true negative. Okay? Yung mga nag-test daw po ng negative, tulad ng sinabi sa description. And we're trying to avoid to detect the false positive. So, yung mga subjects po natin or population or sample size who do not possess the condition or the illness, we do not want them to be included doon po sa ating categorization. So, our test must be specific enough. Next is the positive predictive value. It is the probability that subjects with the positive screening test truly have the disease. And next, yung ating negative predictive value, it is the probability that subjects with a negative screening test truly do not have the disease. Okay, so the definition of terms pa lang naman po tayo. And proceed na po tayo sa ating main discussion. Okay, so for the steps of your epidemiologic study cycle, we will begin with your descriptive studies. So katulad po nung na-mention natin sa ating previous discussion, we have two different types of your epidemiologic approach. We have the analytic and the descriptive. So every problem that we're trying to solve in epidemiology, we will start with descriptive studies as we're trying to describe the phenomena, the health phenomena in a population. So for your descriptive studies, we will begin with data aggregation and analysis. So that will be your step number 1. Next is to build a model and formulation of hypotheses. Okay, kasi nga po, kasunod po ng ating descriptive study is we're trying to formulate the hypothesis. However, hindi pa natin siya gagamitan ng analysis kasi doon na po papasok yung step number 3 natin, which is the analytic studies, wherein we're trying to explain the hypothesis. Gagawa na natin siya ng step-by-step procedure kung saan aalamin natin yung nangyari and meron na po tayong ikakandak na series of tests. Okay, yun naman yung main difference na kay descriptive studies. Kasi kay descriptive studies, we're only trying to describe the place, person, and the time of the health phenomena. Okay, for analytic studies naman po, doon na yung series of testing na gagawin natin. So for your step number 4, the analysis of results wherein the new hypotheses and or further descriptive studies are being conducted as well. So cycle lang po siya on how to do, or these are the steps of your epidemiologic study cycle. Ayan. So as scientists or case investigators, these following steps should be followed in doing an investigation or conducting an investigation for an outbreak investigation. So number 1, we have to prepare for field work. Number 2, establish the existence of an outbreak. So kapag meron pong alarming or tumaas yung mga number of cases of a specific disease, these steps should be followed. Number 1, start po tayo sa preparation of fieldwork. Next is to establish the existence of an outbreak, verify the diagnosis, construct a working case definition, find cases systematically and record information, perform descriptive epidemiology, develop a hypothesis, evaluate hypothesis epidemiologically. Number 9, as necessary, reconsider, refine, and reevaluate the hypothesis. Number 10, compare and reconcile with laboratory and or environmental studies. Number 11, implement control and prevention measures. Number 12, initiate or maintain surveillance. And number 13, communicate findings. So these following steps are not easy to do. So meron po silang timeline na sinusunod from the step number 1 up until the step number 3. So all in all, itong ating outbreak investigation, it will start with finding out what happened or ano yung root cause analysis ng problem on why such these health phenomena happen, and then matatapos po siya sa ating communication of findings or yung pinaka-importante, yung ating monitoring and evaluation. So yung ating epidemiologic approach, dyan na po papasok yun. Yung ating epidemiologic step cycle, dyan na din po papasok yun. If ever na meron tayong outbreak investigation, let's say tumaas po yung mga dengue cases sa ating barangay A. Ayan. So these following steps should be strictly followed. However, we will encounter different errors in your epidemiologic approach or in conducting epidemiologic studies. So number 1, we will be able to encounter a random error or tinatawag nating by chance. Okay? Chance differences in the true and recorded values may result in an apparent association between an exposure and an outcome. And such variations may arise from an unbiased measurement errors. Example, the weight of an individual can vary between measurements due to limited precisions of scales or biological variation within an individual. Example natin, yung mga blood pressure or body temperature, which are likely to vary between measurements. So, itong mga mini-measure natin na mga vital signs, for example, yung mga blood pressures natin and yung mga weight ng individual, meron po yung mga factors to be considered kung bakit nagkakaroon ng variation kapag nagtataka kayo kung bakit doon sa kabilang weighing scale, ganito yung timbang mo, doon naman sa weighing scale nung sa health center, ganito yung timbang mo. Okay, so meron po tayong mga random errors na na-encounter doon. However, we have to address this, lalo na kapag magkakandak na tayo ng studies. Okay, lalo na kung epidemiologic studies yung gagawin natin. So important po na very reliable yung gagawin nating study. Okay, kagaya ng mga blood pressure, important yan doon sa ating study. The effect of random error may produce an estimate that is different from the true underlying value. It may result in either an under or overestimation of the true value. So ito na nga po yung magiging effect niya sa ating ikakandak na study. It may result in either an under or overestimation of the true value. However, meron pong 2 basic ways to reduce your random error. Number 1, you have to increase the sample size of the study. Ma'am, bakit po sabi ninyo So ma'am, bakit ganun? Sabi niyo po, meron pong computation ang ating population if ever na mag-conduct po kami ng study. Bakit sabi niyo meron siyang computation on how to get the sample size? Hindi ka po kami basta-basta pwede manghula. However, bakit sabi dito, in order for you to reduce the random error, you can increase the sample size of the study. Yes, number 1, I said na meron nga po siyang computation, meron siyang formula. And next, suggestion dito is to increase the sample size. Yes, Possible din naman yun. Let's say, meron kang population na 2 million. 2 million healthy individuals. 16-year-old individuals na lang. So, para makuha natin yung sample size, meron tayong gagamitin na Sloven's formula. Then, ang lumabas dyan, let's say, 500,000. So, para ma-avoid po natin yung ating random errors, what we can do is mag-add tayo ng at least 1,000. So, 501,000. So, pwede naman po siya. So, yung pinaka-minimum lang na gagamitin mong sample size is yung according dun sa lumabas sa formula, minimum. So, pwede namang mag-increase para mas ma-lessen yung or mas ma-reduce yung ating random error. Gets po? So, again, if you have your population and you wanted to conduct a study and in order for you to reduce the random error, you can use the formula in getting the sample size. However, pwede kang mag-increase ng iyong sample size or mag-increase ng mga subjects to be interviewed or tested. Okay? Kung ang minimum mo is 500,000, pwede ka naman mag-increase para mas ma-reduce yung mga random errors. Next, we can reduce the variability in the measurement. Okay po. Proceed tayo sa susunod na slide. Okay, so if ever na may ma-encounter tayo na mga errors, katulad ng mga nabanggit natin kanina, like yung ating random errors, it will surely affect the result of our conducted study. It will surely affect the number one, the validity of the study and the reliability of the study. Okay, for the validity, it is the degree to which an instrument is capable of accurately measuring it intends to measure is referred to as validity. For example, in epidemiology, how well a questionnaire measures the exposure or outcome in a prospective cohort study or the accuracy of the diagnostic test. Assessing validity requires that an error-free reference test or gold standard is available to which the measure can be compared. So, para masabi natin na valid yung isang instrument to measure or yung isang study, dapat po comparable siya sa ating gold standard. Okay? Next naman is the reliability. When we say reliability, it is synonymous to reproducibility. Kapag sinabing reliability, it is also known as reproducibility. It refers to the consistency of the performance of an instrument over time and among different observers. Ibig sabihin nun yung repeatability. Okay? Kapag yung isang patient, tinest mo siya sa iba't ibang instrument, tapos nag-yield sila ng same result, it means that the test or the instrument is reliable or it can be done repetitively. Okay? It refers to the consistency of the measurement. Again, pag reliability, pagka tinest mo siya ng paulit-ulit sa different instruments and it yielded same result, okay, consistent po yung resulta, yung blood pressure ng pasyente. For example, yung kanyang weight, yung timbang niya sa different instruments na ginamit natin, it yielded the same result, consistent yung kanyang measurement, even single yung subject natin using the same instrument or under same conditions, we can therefore conclude na yung inyong instrument or yung study ay reliable. Okay? So, next naman, ang mga maapektuhan for a study na merong mga chances of error is yung inaccuracy, the bias, and the lack of validity. So, pag nag-start yung iyong study, nagkanda ka ng study, third year ka na, nagkanda ka ng study, inaccurate na yung mga na-collect mong data. Okay, and then din siya, magiging bias na yan. And then yung study mo, hindi na po siya valid. Okay, hindi na po siya valid. Bias, okay, the bias is a systematic error in an epidemiologic study that results in an incorrect estimation of the association between the exposure and the outcome. Again, when you're able to collect an inaccurate data, it will result to a biased study. Bias is a systematic error in an epidemiologic study that results in an incorrect estimation of the association between your exposure and an outcome. If your study ay maging biased na po, ang next na po dun is magiging invalid na po yung inyong study. Okay, the bias has two categorization. We have the selection and the information. There are numerous ways of classifying and naming the different types of bias. In general, there are two types. Okay, we have the selection and the information. Selection and information. Information can be termed or also known as observation bias as well. Okay. Next po, for the selection bias. Start muna tayo kay selection bias. Ayan, selection bias. Selection bias is an error due to systematic difference between the characteristics of the people selected for a study and those who are not. Again, selection bias, it is the error due to systematic difference between the characteristics of the people selected for a study and those who are not. Very straightforward naman po yung ating description. Next na po tayo. So what are the sources of your selection bias? We have 4. Number 1, the design. Design bias is an error that can occur due to fault in the study design. A studies done on poorly defined populations or with unsuitable control groups. Next po, we have the sampling bias. It occurs when a non-random sample of the population is considered. So sa ating sampling technique, pagka po magta-try kayo na mag-conduct ng study or ng research sa population ninyo at sinabi po ni ma'am na kukuha ka ng sample mo, ng sampling technique mo, hindi pwede na mapiliin mo si friendship or hindi mo pwedeng piliin kung sino yung nasa harapan mo, sino yung readily available. Doon na po papasok yung ating sampling bias or selection bias that is under sampling bias. Kasi po dapat ito ay random. Okay? It will occur when a non-random sample of the population is considered. So, ma'am, paano po siya magiging random? So, meron naman po tayong different applications or software na pwede natin magamit para ma-randomize yung ating sample size. Next, bias in autopsy series arise from the fact that autopsies represent a non-random sample in all deaths. Okay, na yun yung pangatlo. And lastly, your ascertainment bias is the result of failure to represent all classes of persons supposed to be represented in the sample. So very important that tama yung gagawin po nating sampling technique, tama yung pagpili natin ng ating epidemiologic approach, yung ating study design para maging valid and maging okay po yung flow ng ating ikakandak na study. Ayan. Next is the information bias or what we call the observation bias or measurement bias. It is an error due to systematic differences in the way data on exposure or outcome are obtained from various groups, leading to misclassification of study subjects. So what are the sources of your information bias naman po? We have number 1, the recall bias. Okay, number 1. Recall bias occurs when individuals remember differently previous events. So iba-iba na yung na-recall nila ng mga pangyayari. So number 1 na doon, papasok na po yung mga errors natin dito. May encounter na tayo na errors. Number 2 is the prevarication bias. It results from selective revealing or suppression of information. So, hindi po nire-reveal lahat. Meron tayong mga hindi dinedeclare na information. It can be categorized as bias kasi hindi na siya masasama doon po sa reporting ng ating mga study. Number 3 is the reporting bias. It occurs when the data source in one study group differs from the other study group. Next, the loss of follow-up or what we call the withdrawal bias is expected to occur when a prospective study with a long follow-up period. So let's say meron tayong prospective study na nandun sila sa isang control group. And then along the way, nung nagkakandak tayo ng study, let's say ang timeline natin dito is in 5 years. 5 years po yung ating study kasi let's say gusto mong malaman kung yung malunggay extract ba is nakakapagpatubo ba siya ng hair dun sa mga patient natin na napapanot. So, naka-control group sila sa nandun sila sa study na for a 5-year study. And then, suddenly may mga patients na nagwi-withdraw for some reasons. Yung iba, ayaw nang mag-continue. Yung iba, namatay. Yung iba naman, nagkasakit. Yung iba, lumipat na ng lugar. Or yung iba, ayaw lang talagang mag-continue sa study. So, dito na po papasok yung ating loss of follow-up or yung mga withdrawal. Next is yung missing data. They will all fall under the information bias kasi as you can see, meron nga pong mga kulang na data kaya pumapasok sila sa information bias. So yung mga data na to, these are very important para mas maging valid pa and yung ating mga study. So missing data bias is expected to occur when incomplete records, okay, so very important na kompleto yung mga data natin, are chosen as source of your information. So very important na kompleto po sila. Next, sources of information bias can be categorized pa rin po into digit preference, the observer or the interviewer, and instrumental. So the digit preference bias may occur if the study subjects or observers, or what we call interviewers, prefer differently certain numbers, leading to differences in rounding up measurements. The observer or the interviewer po bias results from systematic differences in repeated measurements from the same observer or your intra-observer, or inconsistencies attributed to differences in the way applied by the different observers. So the instrumental bias naman, yung pinakahuli, is due to faulty calibration, inaccurate measuring instrument, and contaminated reagents, incorrect dilution, ganyan. So for the epidemiologic approach, important din yung mga instrument natin na well-calibrated sila and wala po tayong ma-encounter na error so that our reporting are all valid. Lalo na kung ang study mo, nagkakanda ka ng study na gusto mong malaman yung blood pressure nung iyong population sa barangay B. So kung hindi po calibrated yung iyong ginagamit na pang-BP, yung iyong sphygmomanometer, may magiging faulty nga yung iyong resulta. Next naman pong source ng ating information bias is the detection, workup, lead time, and the length. Ayan. Again, if you are able to encounter this information bias, okay, or you have data that are incorrect or incomplete, misclassification, dito napapasok yung misclassification of groups, and spurious associations may be introduced. Okay, misclassifications may affect both groups and mask the true association between random or non-differential. Misclassification also may affect only one group, leading to either overestimation or underestimation of an association. So next, how do we control this bias? Okay, number one, we have to prevent. Next, to study and to evaluate. Very important na naka-monitor tayo doon sa ating mga test subjects or yung mga ating patients or ating mga subjects for the study. So, very important po na naka-monitor tayo because bias cannot be usually totally eliminated. Again, it cannot be totally eliminated. The aim, therefore, must be to keep it and a minimal level. Minimum lang. Meron man, pero sobrang liit na lang ng chances na maka-encounter tayo ng bias. To identify those biases that cannot be avoided, to assess their potential impact, and to take this into account when you're interpreting the results. Ayan. So how do we prevent these bias? Number one, we have to do good, or the sampling size, the sampling technique, and the study design must be correct. Must be studied very well, and dapat siyang tama. Dapat tailor fit siya doon sa iyong objectives, also doon sa goal ng iyong study. Next, the sources of the data collection, the methods of data collection, and the content of the information. So next, the measures of your diagnostic efficacy. So for the sensitivity, it is always expressed in the percentage, and 100 times. The formula is 100 times the number of the deceased individuals with positive test, total number of the deceased individuals tested times your 100. So for your sensitivity, the goal is to know the true positive. Alin po yung totoong nagpo-possess ng characteristic who in the population are true positive. So to avoid detecting the false negative. Okay, we do not want to miss out yung patient na na merong cancer, for example. So, kailangan po sensitive yung ating measurement. So sensitivity percentage, how do we compute it? The total positive divided by the true positive plus false negative times 100. Meanwhile, for your specificity, it is always expressed in percentage as well. The number of individuals without the disease with a negative test total number of individuals tested without the disease times 100. The goal is to know who in the population are true negative or who do not possess the characteristic. Okay? The goal is we do not want to miss out or we do not want to detect false positive. So, hindi naman po sila cancer patients or they do not contain the cancer cells, tapos na-categorize mo sila as cancer patients. So, dapat po specific yung ating measurement and specific, very specific yung ating study design. So, the formula is specificity percentage is equals to the total negative or yung TN divided by true negative plus false positive times your 100 and expressed as percentage. Ayan. So, same as for the positive predictive value and negative predictive value. Yan lang po sila. Yan lang yung kanilang formula. Ayan. So, kung may makita man kayo na examples on your module na table, kailangan nyo lang po siyang i-categorize or alam nyo kung paano nyo i-identify alin doon yung PPV, alin doon yung sensitivity, alin yung true negative, total negative, yung ganon. Pagka na-identify nyo na which is which, and then that will be the time that you will compute for the efficacy. And then you will apply this following formula. Okay, so that concludes our discussion for today. If you have any questions and clarifications, do not hesitate to contact me. So thank you and God bless.